Hi, my name is Guadalupe. The phenomenon I will be introducing is how images change when looking through water. The physics behind this is refraction. Light waves travel in a straight line, but when there is an added factor slowing or speeding up the travel of light, the image you see looks warped. For example, light travels slowly through water but travels faster through air. To conduct this experiment, the materials needed are water, marker, glass, and paper. First, I drew 3 arrows going to the left. The arrows make it easier to understand how light bends when seeing it through a different material. Looking through the glass without water, you can see the arrows are pointing a certain way. When there is no water, the light bounces off the arrows, making you see the original image. Then, once you add water, you can see they change direction. What's happening is that the light bounces off the arrow into the water, but the light waves travel slower, which bends the image of the arrows so it takes a curved angle. This makes it seem that the arrows change direction. To further explain, normal is a term used when talking about angles of refraction. Normal is an imaginary line that stands at a right angle to the surface. The blue line represents the normal. The orange line represents the incident ray. As you can see, the light source is touching the water. Another thing is also happening. This is called reflection. Reflection is when light moves onto one material and it bounces onto another. The ray continues in a straight line, but at a different degree. Following the red line represents the refracted ray, also known as angle of refraction. Although I did not add it in, when the light exits the glass, it is called the emergent ray. Here it is all put together. The orange line is the incident ray, the red line is the refracted ray, and the white line is the reflection. Here is a much clearer graph. The incident ray is the light wave. It travels fast in the air, but once it hits the water, it slows down. This is what gives it its curved angle. To put this in a real-world example, think of your eye. Your cornea acts as a convex lens, so when the light rays enter the cornea, it becomes refracted, then connecting with one another and pointing toward the focal area. Because of this, we are able to focus on an object and be able to see it clearly. In the next clip, you'll be seeing me perform the experiment.